Alright, Hex Grid Map Maker, Devlog number 2. Thus far we have made substantial progress on our hex map. As you can first of all see, just right here, we're able to create both hex and grid shape simultaneously. Um, After further testing, we have realized that there's actually no need for a grid chunk. So whereas previously we had used the grid chunk class to separate the hex, I now realize that that's actually not as important as I once realized. We can instead use these layers and then add these layers to a grid chunk later on. But for the time being, we can just spawn the layers directly. As you can see, we have two types of layers. We have two types of shapes to be honest. A layer can take on any shape, right? But a layer can only have one shape. So in this case, for example, we have a hex layer and a square layer, and the code for these is actually quite simple. Let me see if we can find that rectangular. So it's actually quite simple. So of course you can then inherit from the grid shape class originally initially. You set the vertices, you set the triangles, UVs and whatnot for rectangles and for hexagons, and then most importantly you set the test later position. Now for rectangles it's quite simple, right? For hexes it's a bit more complicated, but still, uh, once you've done that, you have now our layered meshes. The layered mesh class has actually been revamped quite a lot in this commit. As you can see, it's simpler in a sense, right? It takes on just one parameter when you initialize it, which is the grid shape, right? A layered mesh can only use one grid shape, and then once you've set that grid shape, you have other things you must take into account for. For example, we must take into account the render layer, right? So if you look at this over here, and towards in the future, we will be able to choose what layer we wanna display our hexen. That way you can essentially set which layer comes first when it comes to render and which layer goes backwards and whatnot. Um, Additionally, we have things such as you can now insert things directly into a layer, right? So whenever you say I want to insert a hex into the layer, I give it the visual data and the grid position. Now this is also a brand new thing we've just made with this commit is the visual data, and I'll show you that right now. So let me just cancel these things real quick. Container mesh quick. All right, and all right, let's go with these things for example. All right, so we have three main components here. So we have of course the main visual data class. We have a container for visual data, and we have essentially a quick visual data class. Now, the quick visual data class simply allows you to set a texture and a color, right? Because these are like usually speaking the two main ways in which you essentially create your hex. So either you give your hex a color or you give your hex a texture, right? And then by utilizing the materials property class, we can essentially, in a sense, skip the need to create multiple materials for one type of visual data, right? So let's start over here, for example. Each visual data comes with a special attribute which is called its hash, right? And essentially, all this hash does is that we simply we simply make it so that any hex that looks a certain way will have a certain hash, right? So essentially, if you have many hexes that look the same, and all those hexes have the same have use of visual data, in when we render the code, we can simply use one material for all of those hexes instead of having to do one material per hex, right? And that is what our visual data allows us to do. What's more important about this visual data though is that since we are utilizing the material property box, and since the user themselves can use their own materials, it is not required that I supply them with a custom material, right? So for example, I have my materials here I just made. It's very simple. Let me get this. So I have a shader I made. So this is my simple shader. All it has is the main text. All it does, it uses the main texture and the main color in order to call the hex. That's really all it does, right? But if you had your own custom shader, you could in fact actually just make it yourself, right? Make it yourself and then um pass it in here. So look at this, right here, right? Let's see who uses this. So if we come down here to our quick visual data, when the user makes a texture, right? When they pass in a texture, all we're really doing is that we're simply creating a material property for that texture, right? So when you do props.set texture to main text, all that is doing is setting the texture of this property right here, right? And essentially, what you would have to do as a user is you would have to create all of the visual profiles of your map, right? And then you will create you would then create all these visual profiles and then add them into a then put them into this class called a shape visual data, right? And then you can then essentially put a list of all those profiles into your container, into your shape container, right? And each visual data comes I think with a name property. Is that a name property? I haven't added it here, but I think over here there's a name property, right? And then in your in your container, you can then access that specific shape visual data using your name. For the time being, I don't know why I forgot this, but I haven't added it in here. But you'll be able to. And so you can see right here. I also have this quick get random method, just so that we can easily do our testing, right? So if we come back to our grid manager, all what we're doing here is that we're simply going to initialize each layer with the correct shape. So the hex layer gets the hex shape, and the rectangular layer gets the rectangular shape. And then we loop through the grid size. And all we're doing is that we come into each layer, and we essentially insert that particular shape visual data, which we got from our containers. Remember the containers with the which contains our visual data. So all we're really doing is that we will get a random shape visual data from that container and insert it into that position, as you can see over here, right? And then in our layer mesh, will actually then hold a dictionary of visual data, right? So if you were to insert a hex, right? If you were to insert two hexes that had the same visual data, right? Instead of having to create two separate materials, all we would have to do is simply create one material, and then tie that specific hex into that one material, right? And that's all what we're doing here, right? So when you insert a new hex into that position, all what we're doing is that we're gonna say, okay, hey, do we already have this visual data in our layer? If we do, we just insert the mesh in that specific position, right? That specific offset, that the test layer position. If we don't, we create a new fuse mesh, and we add the new visual data. When that is all done, when we've done all of that, we can then come back into this method here called the update mesh, and the update mesh calls this method called the combine fuse meshes, right? So imagine now we have all these sub meshes. I'll show you real quick, guys. So now we have all these sub meshes right here. So essentially, look at this. We have 4 sub meshes, right? 1, 2, and 3, 4. All of these sub meshes were part of the dictionary, right? They were their own distinct. They all had their own distinct visual data. Okay, right? However, before they became sub meshes, they were their own. They were their own. What do you call them? They were their own unique meshes. Now the reason why we combine all of them into one mesh is so that we can then display it using one renderer, right? If we wanted to display those meshes individually, we would have to create 4 individual mesh renderers, which is very ineffective. But instead, what we can do is that we can then combine all of those meshes in this method over here into one mesh, and that one mesh would have sub meshes. And then once we can then set the materials, right? So remember back to this dictionary we have. Each dictionary has a shape visual data, and each shape visual data has a material, and it will have the material property block, which contains the properties for each for your materials. So remember, as I told you, we had over here we set the main texture of our property to the texture, right? So that's all we're doing here. So when we combine our meshes, when we combine our meshes using the set materials, first we clear out blah blah blah. We go through it. First we get the material. Then for that material, for that specific material, we create a property block, and then blah blah blah. And so what you have now is that now we have four different materials, right? For those four submeshes, right? And each of those four materials gets their own will have their own property blocks, okay? And that essentially allows us to have one material. So all of these materials are all of these materials, by the way, I should point this out. They're all essentially the same instance of this one shader layer, right? It's the same instance, right? That way we're not creating four separate materials down here, right? If all of these materials were a different instance, for this material down here you'll see four of these, but these are all the same instance, right? But all of these instances can run their own material property blocks, right? And this is essentially where the performance gain of our layer comes from, because we have what we're displaying over what's this for each layer. We're displaying essentially 400 hexes, but all these 400 hexes you see over here are being displayed using one material, right? But each material has a different property block, right? That's why they can all be different colors and whatnot. Okay, so once we combine our meshes, we set the once we combine our meshes, we set the materials properly. We set the materials for each submesh. So for each submesh, you get the material. You get it for each mesh essentially. You get the visual data, and the visual data contains the material, and it will contain a property block. If the property block is null for whatever reason, we will simply create an empty one. Okay, and then we get the mesh renderer, and the mesh renderer will be this right here, this component over here, the mesh renderer, and the mesh renderer will give us has this array, this materials array, right, which is over here. We use the shared materials. That way we can notify Unity that the material we're gonna use here is one instance, right? But it's gonna be one main instance, but there are gonna be four instances of it. That makes sense. So you have you would have essentially the main material, right? The main material, right? But you're gonna have four instances of that material, right? So that way, so all of these, they're references. That's what I'm looking for, references. So all what we're doing here, so all of these over here, all of these materials are simply referencing this one material right here, right? All of these, they are referencing this one material, right? Reference. However, each reference has its own block, right? Each reference will have its own material block, right? And again, I don't want to repeat myself, but as you remember, the material block will simply set a specific property value for the material properties, right? So each one will have its own block, right? So at the end of the day, if you look at what we have, all we're doing is using, it's still just one material. It's all just one material, but each material has its own reference and its own property block, right? And that's what we're doing here. It's the same thing with rectangle. It's just one material, right? But each material has its own property block. And then once you set the shared materials, you also then set the property block. So if for each shared material, once you set the shared material, you then loop through that shared material, and then you set the property block for that specific material, and that gives us this. And this is where we're at right now. Now I'm going to show you guys how this will look like in the editor. Okay, so I've just shown you guys the code, and let me show you how this will look like in editor. So let me first clear out this grid. Okay, so first and foremost, we have our container. Okay, we have the grid manager will have our container, and this container will contain all of your unique visual data. So we have our container here, and our container, by the way, is going to be a scriptable object. Okay, that way we can modify it and save it with the editor. And let me clear it out. So let's just say I want to create. I have these textures. Let me show you guys my textures real quick. So I have these base textures that I have over here. These are some textures that I have that I've acquired from the asset store, right? Now, if I wanted to create, a hex with these particular textures, what I will have to do now? So I'll go into my Visual Maker, right? Right, and it comes, and I'll create a quick visual data, right? So boom. Now let's just say I want to create a grass texture. Let's call it grass. Let's call this grass. Let's call this. Then we're gonna use that base material I was talking to you guys about. So remember, my base material, we use this base shader over here, guys. All right, and then I'll set the texture to grass. Let's just I'll use this grass for example, right? Now, obviously, I want to use just the grass. Um, my material we either use a color or we'll use a grass. If the color is black, that means use the texture. Or if the color is not black, use the color. Okay, that's what this means, by the way. So we keep our color on black, and as you can see, guys, each visual data will create a unique hash. Now, I know what you're thinking. What if we create a visual data with the same hash, right? So if you look at this, if we add this, as you can see, these two visual data have the same hash, right? Well, this might occur if you want to use the same texture, right? But then down the line you can change it. You want to change it later on. This is why I provide you with this unique seed over here. That way you can then create your own unique seed for visual data for a visual data that will be temporarily the same. Okay. So I'll just say I create grass here. Let me create some water. I'll just use this water over here. Unique, just put that back to 0. Let's say I want to do a color. Let's do a color green. No, let's do a color yellow. A yellow color. Alright, let's do yellow color. So if remember the texture takes precedence. So I'll remove the texture. I'm gonna remove the texture, put a yellow color over here. Okay, and set the alpha 0 to up. And let's do one more. Let's do two more. Let's do a color red. Red color, I'll call it base material, and I'll put this on red. And let's do one more texture. So let's call this texture snow, and we're gonna use snow texture, and then we're gonna set this to white, to black. That way our shader knows not to use it. And so this is gonna be what we have over here, right? Then we would then come to our GridMap tester, and our GridMap tester will actually I've actually made it so it will fill the dictionary for us, right? So let me remember that this was the list we were just modifying, right? This list over here, this quick visual data, it was this list. However, what we're gonna do is that this dictionary exists, and this dictionary is where we get our data from. Okay. We can also get it from the list, but towards the future we're gonna use a dictionary so that it'll be much faster retrieval time, right? Because you never know, you might have over 100 different visual data, right? And so you wanna really boost your performance as much as possible. The last thing you want to do is you don't want to have to search through a whole list every single time you want to attain a specific visual data. That wouldn't be good, right? And so anyway, I think one thing you can do with the dictionary too is that you can actually use an enum here, right? So instead of having strings, you do an enum. Or you can even do a constant class. No, well, let's ignore that. We're gonna out of hand. So anyways, so we have the validated visual hash, and all this button does, this validate is down here, is that all we're gonna do here is that we're not gonna like validate the hash code. So when you validate the hash code, we simply make sure that the hash code is accurate. And so when you do that, we can then fill in the dictionary, essentially add all of the values from the list into the dictionary, and then boom. So I think we have everything we need now, right? Everything has been. We didn't even clear these out, by the way. We're gonna actually just remove. Okay, just to prove to you guys this works, I'll delete this right now, right? Then I'll create a new object, call it hex layer. And I'll create another object. I'll call it call this rectangle layer, right? And all you have to do is add in that layer mesh. That's it, right? That's all what the user will have to do. Just add in that layer mesh. That's it. That's all you have to do. And once that's done, we make sure everything we drag and drop into our hex layer. We drag and drop into our rectangle layer, and we generate. Boom. That's it. Now you're thinking, oh, why is this all messy? Remember, guys, they're the same position. It's a layer. All you have to do is just move it aside. Boom. As you can see, voila. That's it, right? That's all what you as a user have to do. And so since we're editor mode, let's run this in plain mode. Let's see what our FPS can be. Ah, I don't know why this happens, but what's going on here? Let's see this. Can we generate this? Okay, good. So look, so it's in play mode now. On our FPS, it's 140, 155. I'm pretty sure I have VSync on, so it's pretty much capped. But look at the amount of draw calls we have, you guys. 12 draw calls, and you might be thinking that those draw calls are because of our shit, or because of our materials, but it's not. So if we go into the frame debugger, right, we can then see our draw calls and see what's actually being drawn, right? So let's look at this. Let's see how many draw calls it takes to actually draw our hexes. Okay, so here we are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. So to draw both layers, it took 10 draw calls, right? That's actually pretty good. Because remember, each give me a sec. Each layer is 400 hexes, and these 400 hexes have 1, 2, 3, 4, 5. Have 5 material instances, right? So instead of having say 100 different material instances, we only have 5 because we have grouped them together. Okay, and that's essentially where we're at right now. And not only that, but these are 5 unique what do you call it? These are 5 different visual datas, so they all look different. And so that's where we're at right now. And towards the future, you will be able to create your own custom shapes. And this package, this asset, I plan on adding custom shapes so that you don't have to create a lot of them. So we've already made hexes, we've already made triangles. I mean rectangles, and yeah. Towards the future, what I see happening is how can we best put this? For the time being now, I think essentially this is pretty much it. Like, this is a lot of the work has already been done, right? I think now we really need to work on those layers in the sense that each layer must actually be set towards a proper layer. Can we set this? No. Nah. So I think now we actually have to like work and making sure these layers are set in their right layer, right? We also have to make sure that the grid chunks are that we will be able to properly disable these layers, right? So for example, let's say that you want to disable one layer for whatever reason that may be. We should make that simpler for you. We also want to be able to so the grid chunk will now instead carry a bunch of layers, right? So this way, and the reason why this is a good thing is because from this point forward, I don't think we will be bounded to only square grids, right? I mean, to only square chunks, right? If you look at a lot of games, let's see, you have a picture here. Do I have a picture? Nah, I don't have a picture. But a lot of games actually have irregular shapes. All right. For example, if you like I think with Hearts of Iron 5, I mean Hearts of Iron 4. If you take a look at their map, you should be able to simulate this. Let me see if I can. Exactly. For example, look at this little thing right here. This little boundary. All right. That could be a chunk. Okay. No longer, it doesn't have to be square anymore. And that's where, and this is where we're pretty much at. And towards the end of this project, you should be able to create essentially a map like this one, okay? And then you can actually just set each country to its own chunk, if you wished, right? I mean, you can make it out of squares or out of rectangles, right? And not only that, but you can also individually set. Remember, how you'll be able to individually set the size of each square, okay? So remember, if I wanted a big square like this, look at that. That's easily done, right? And so this is essentially where we're at right now. I can do the same thing for our hexes, right? Easily done. Let me move this hex real quick. Move this. Boom. Right? Look at how easy that is. And yeah. And one more thing is that towards the future, I should put this out there, but we should be able to edit this in the editor, right? So you guys know how like the tilemap, for example, the Unity tilemap allows you to modify your things from the editor. So instead of doing this instead of having to go into your code and then do random visual data, you should be able to do this. You should be able to do this from your editor. You would just like click on the hex, boom. I want make it yellow, make it red, make it green, or whatever. So we're working on that part. And yeah, that is pretty much it for this devlog. And see you next time.